Right, so just like we did with our mean, we talked about visualizing, we talked about what this means in context, and then we're going to go through and we're going to talk about calculating this. There are going to be a couple of cases where you're going to want to be comfortable calculating our standard deviation by hand. However, this is definitely something that we're going to be heavily reliant on StatCrunch in. So as we go through and as we start looking at the next few examples, this is definitely something where even if we didn't use StatCrunch to help us at all in Chapter 2, you are going to have to be using StatCrunch in Chapter 3. Otherwise, trying to do your calculations by hand is going to be nearly impossible. Your rounding could end up off, so it's going to be easier just to use the computer to assist us with this. Again, I'm going to have some extra links that walk us through using StatCrunch step by step, at least using a PDF, and I might actually put one example kind of going through a video for one of the examples to show through how we can enter all of these values and calculate all of these things step by step for this chapter. Good news is not a lot of commands to remember for StatCrunch. We're going to be doing a lot of the same thing over and over again. All right, so to calculate our standard deviation, we're going to use the letter S to be representing our standard deviation. It is going to be the square root of the sum of all of the deviations from the mean in the data set divided by the number of observations. Obviously, that's a pretty wordy definition that we have there. And it's a pretty complicated looking formula. So we're going to kind of try to piece this together a little bit here. S is standard for standard, is representing or standing for the word standard deviation. What we see in parentheses, we're going to take x minus x bar. X are still our individual data points, x bar is our mean. So our mean is going to be used in this formula. We're going to be squaring values since we see an exponent there. We're going to be adding values since we have the summation sign here. N has to do with our sample size. So we're going to go through and kind of walk through this step by step. Again, our instructions for StatCrunch are actually exactly the same as finding our mean. We're given the mean and our standard deviation at the same time. So we enter our data values into the column table. We go to Stats, select Summary Stats, and that gives us all the information that we need, honestly, for, again, most of Chapter 3. All right, so again, we do want to make sure that we feel comfortable walking through this process without using StatCrunch. So there is a little table here that's set up. This table we're going to set up to use, and we're kind of labeled step by step as far as how we're going to calculate our standard deviation. All right, so in order to find our standard deviation, the first thing we're going to do, so if we notice next to step 1, we're going to find x bar. We're going to find our mean. So up here we see our data values. So we're going to add these guys together. This 6 plus 8 plus 9 plus 10 plus 12 plus 15. And if we add those up, we get a nice even 60. And then we're going to divide it by the total number of data values that we have. We have 6 numbers, so we're going to divide that by 6. And that gives us a mean of 10. So the first thing we have to do if we're finding standard deviation is to find our mean. All right, then now the next thing I'm going to do is I'm going to fill in this column in our table. And notice that this column is represented by x minus x bar. So x are each of our individual data values, which I've gone ahead and filled in. If you're creating a table from scratch, you're going to start with your first column of x and then just list all of your data values. So all 6 of our data values have been listed here. All right, so now we're going to do this step 2. We're going to do our subtraction for each of these. So we're going to take x minus x bar. So that means that this value comes first and we're going to subtract our mean. So 6 minus 10 gives us negative 4. 8 minus 10 gives us negative 2. 9 minus 10 gives us negative 1. 10 minus 10 gives us 0. 12 minus 10 gives us 2. 15 minus 10 gives us 5. All right, so we do want to make sure we get these in order. Again, our individual data value comes first minus our mean. So we're always subtracting 10. All right, now step 3, notice that I have the same thing from that previous column, but in parentheses and squared. So that's what we're going to do here. So negative 4 squared. Remember when we square negative numbers, they turn positive. Negative 4 times negative 4 gives us a positive 16. Negative 2 squared. Negative 2 times negative 2 gives us positive 4. Negative 1 squared. Negative 1 times negative 1 gives us positive 1. 0 squared. 0 times 0 is just 0. 2 squared. 2 times 2 is 4. 5 squared. 5 times 5 is 25. All right, so that was step 3. We square all of those deviations, all of those answers that we get to our subtraction problem. Now notice down here I have a little step 4, and step 4 is in the row with our sum symbol. So that means we're going to take all of these values and we're going to add them up. So I'm just going to add them up mentally here. 16 plus 4 is 20, plus 1 is 21, plus 0 is still 21, plus 4 is 24, plus 25 is 50. So we add these up here, we get a total of 50. All right, now we're going to come full circle. We started with step 1, step 2, step 3, step 4. We're working clockwise. We're going back over here to step 5. So in our formula for S, we're going to take our square root of what we just found in that table. So 50 divided by n minus 1. So our sample size minus 1. Our sample size was 60. So not 66. We had 6 values. So we're taking 50 divided by 6 minus 1, which is really just the square root of 50 divided by 5. We can type this into our calculator doing a couple of different ways. 50 divided by 5 works out evenly. If it doesn't work out evenly, then we want to make sure we type this into our calculator using parentheses, or doing the square root symbol first, put 50 divided by 5 and then closing it off. And this is going to give us an approximate answer, which I'm going to round to 3 decimal places, of 3.162. So there is our standard deviation. All right, then last but not least, we're asked to explain what this means in context. Right? Interpret our standard deviation. So again, this is going to be something that we're going to be asked in a lot of the problems that we're going to see. So the idea of what does this mean in context, interpret this answer, is going to be a common thing that we're going to see in Chapter 3 and in Chapter 4 as well. All right, so standard deviation, remember, means most. Most meaning, right, about 2/3. Right, so the majority, about 2/3 of the numbers in the data set if we were talking about something more specific, if we were talking about ages or something like that, we would put ages in there instead of numbers. Right? But about 2/3 of the numbers in the data set are within 3.162 units of the mean. And again, depending on the context of our problem, instead of using words like numbers and units, we could see things like ages and years or something along those lines. Right, so obviously looking at this, our standard deviation is going to be a little more complicated. We definitely have a more complicated formula, a lot of pieces to fill in, a table to fill in order to get this result. And then once we get this result, we go ahead and explain what it means in context. What we're going to see in the next example is going to be the information that is given to us from StatCrunch, and you will be able to find in this next example a video and PDF online in D2L that's going to explain how we get this answer, how we get this information.